This is the second video in the series entitled Improv Card Magic. Now today we're going to work with 6 card packets, and this will give us practice looking for and recognizing these 3 special structure types, and then we will show you how we can preserve them and convert them from one to the other, and then in the end finish with a very surprising reveal. So let me bring up those 3 structure types. The first one is a 2-cycle structure, abbreviated 2C. The second one is a mirrored structure, abbreviated by the letter M. And the last one is an AMP, and that stands for adjacent mirrored pairs. Now, as in the first part of this series, at the bottom of the screen you'll see simplified examples of each of these 3 structure types. So for the video today, we just need 3 piles of 6 random cards. So 3 piles of 6. If you were here, I would have you mix the cards to your heart's content. I've mixed them quite a bit off of camera already. Okay, let's check to see if I've done that correctly. So I just need 3 piles of 6 cards each. Okay, I believe that's the case. Okay. And so what we're going to do is do a little bit of practicing looking for either interesting 2-cycle structures, mirrored structures, or AMP structures. Okay, so let's go ahead and look at the first one. Okay, here we go. I want to remind you of something that I mentioned in the first video. The idea of randomness is probably not well understood by most people. Randomness is actually what they call clumpy. So you would think that if you have 26 red cards and 26 black cards, that it's not likely that you're going to get 3 red cards, and in particular 3 hearts in a row. Most people would look at that and say, that's not looking very random to me. And people probably think something like an alternating packet, red, black, or close to that, is more random than the one we're looking at. But that honestly is not the case, because with a random ordering of a deck of cards, you will get strings of red cards next to each other, or blacks, or even a number of hearts right next to each other. So this is not unusual when dealing out 6 random cards from a shuffled deck. Okay, so let's go ahead and just take a look at the structures here. So why don't we begin with the 2-cycle structure? Well, if you remember what that means is kind of in your mind's eye, I'll jog the cards so that we can maybe focus on the important features. So here what's happening is we're looking at the cards that are in the same position in their respective cycles. So we're thinking of this as like 1, 2, 3, and then a repeating pattern of 1, 2, 3. So what that means then is 5 of clubs is in the same position as 6 of hearts within its cycle. So we would say those 2 are related by position. These 2 are related by position, which is kind of nice because they're both 2s. And then the king and the 3 are, quote, related by position within this 2-cycle structure. Okay? So what do you notice there that might be interesting to reveal? Well, one thing that we could reveal is the fact that we matched up the 2s. So we put this packet of 6 cards through just tremendous mixing, and then in the end we're able to set out pairs where one of the pairs consists of these 2 2s. And if you think about it, how likely would that be? Not very. Okay, so that would be one interesting characteristic that we could reveal if we view this as a 2-cycle structure. If we focus just on red and black, I guess the 5 here and the 6, those are opposite color, opposite color, opposite color, so that's kind of interesting. They're all of different colors. So if you made note of that, you could, in the end, separate these 6 cards into 3 piles of 2, where one of them has the 2 2s, but also you've done it in such a way that the other 2 pairs are of opposite color. So that could be kind of fun to reveal. Now, as a mirrored structure, what do we see? Anything interesting here? So mirrored is where you look at the end cards and then you come in one at a time. So here we get black 5, black 3, same color, that's curious. Oh look, we still get, which is, it doesn't happen very often, we still get the 2s related, even in a mirrored relationship. That's kind of fun. And then the middle 2 would, quote, be related, because they are the mirror image of each other in terms of their positions. So if we wanted to focus on colors, we could say, well, there's one black pair, there is a pair of 2s, opposite color, and then there's also a red pair, a king and a 6. The final structure type that we could work with if we wanted is an AMP. So this is where, and maybe I'll jog the cards a little bit so we can focus on the essence of an AMP structure. This is where you take them in pairs from the top. So in particular, I guess we notice that these are of opposite color, so that's interesting. These are of the same color, right? This king and the 6. And then the 2 and the 3, those are the same color. So if we viewed this as an AMP, we could match up the cards in such a way that there would be a red pair, a black pair, and then a pair that doesn't match in color. Okay, so that's kind of interesting. Something else I just noticed regarding an AMP is the fact that these 2 cards here have the opposite parity, meaning this one's odd and this one's even. If you recall, a king is a 13, jack's 11, queen's 12. A king is counted as a 13. So a 13 and a 6, those are of opposites, parity as well. And then these 2 also. A 2 is even and a 3 is odd. So that might be kind of fun to reveal. But maybe we'll go with that one. That's kind of a fun one to go with because you've matched them all perfectly according to opposite parity. Curious. Okay, so let's go ahead. So what I'm going to do is, so we'll call this pile 1 in just a moment. And so we'll just say the pairs, in fact all of them, have opposite parity. That's just a statement regarding whether the card has an even value or an odd value. So opposite parity. Okay, so why don't we go ahead, we'll go ahead and declare this to be our, quote, first pile. We'll put it right there. And this is what we'll reveal in the end. Let's take a look at the next one. Now, it may be that we don't, we may use this one for that one. It just depends on what we find that seems to be the most interesting or most surprising. Okay, so here is our second random packet of 6 cards. Okay, so quickly, as an AMP, what do we see? Well, we see a non-matching color pair here, a non-matching color pair there, the queen and the 3, whereas the 2 and the 8 match in color. So that's kind of interesting. So if we were to view this as an AMP and go through and mix it, we could eventually put out the cards in pairs, where the pairs would be this set of 2 here, these 2, and then finally those 2. And then you would be able to say, boy, we've mixed these in such a way that one of these pairs consists of 2 even value cards that are, I think, the same color. I think I can see that in my mind's eye. Yeah, one of these pairs is like a 6 and an 8 or 2 and a 4 or something, and they're both red. And the other pairs are of opposite color for sure. I can just see that. Okay, so that's the kind of thing we could do at the end if we choose to view it as an AMP, which you don't have to. So let's go ahead and look at it as a mirrored structure. Okay, so this is where we look at the outer ones. and say, okay, is there anything interesting about those two cards as a pair? Well, they're of opposite color. They're opposite parity as well, right? Jack is an 11. Coming in one. Oh, that's very nice. Look, we have a 3 of diamonds and a 2 of diamonds. That might be worth revealing. And then if you come all the way in, we just have 2 cards of the opposite color. Okay, so if we chose to view this as a mirrored structure, what we could do is say the pairs consist of cards of the opposite color except for one of the pairs. And that one pair actually is a pair of diamonds. Wow, isn't that interesting? Okay, so why don't we, okay, so we looked at this as mirrored. Okay, why don't we take a look at it as a 2-cycle. Woo! Okay, look at this. The Jack and the 3 are related relative to the 2-cycle structure of the packet. Those two are both the first cards in their respective cycles. And look, they are of the same color and suit. Move one over. The 3 and the 2, same color and suit. And then we get another pair, Queen of Diamonds and an 8 of Hearts, the same color, which is nice, but not quite the same suit, but that's okay. So what we could do is if we viewed this as a 2-cycle structure, we get the cards matching in color and in suits, except for the silly Queen and 8 here. Okay, and so if you can kind of squirrel away that information and say, boy, at the very end, you know, when you get to the end, you can say, boy, these pairs, I don't know, they all feel like they're the same color within each pair. I wonder how many of them are of the same suit. Boy, how likely is that? And then you could say, well, I don't think they're all of the same suit. I think one of these is like a heart and a diamond or something. But the other 2 pairs actually match in suit. Wow, how in the world could I possibly sense that? After randomizing the cards, using the shuffles, and making the choices that you, the spectator, made. That's amazing. Okay, so why don't we go ahead and do that? So we're going to view this as a 2-cycle structure. And so really all you have to remember is that 2 of the pairs will match in suit, actually. Great. Those 2 and those 2. You don't have to remember what suits they are unless you want to. I mean, the more information you can kind of recall, the more powerful the reveal would be. But just to say that we have 2 pairs of the same suit, that's pretty powerful. And then you could point out, well, the other pair is not bad. They actually match in color, but not suit. And I think they're red, maybe. I'm not sure. Okay, so let's go ahead and write that down. That sounds like a great way to go. So this could be pile 3. So we could say 2. I'm just writing this down for us because, well, you know, for us to remember all 3 of these at once, it's going to be kind of confusing. So 2 pairs where it's the same suit within each pair. And then we have one more pair plus 1 pair. I'm not sure why I put that in parentheses there. Sorry about that. 1 pair, same color. Oh, we could even say 1 red pair. Yeah, well, let's do that. I don't think that would be too hard to remember. Okay, 1 pair, that's red. Okay, so 2 pairs of the same suit and 1 pair, and they're both red, but they're actually not of the same suit. That's kind of interesting. Okay, so let's put this away. This will be our pile 3 in just a few minutes. And then the last one, I guess we're kind of forcing to, whatever the mirrored structure gives us here, we'll go with. But the amazing thing is there's almost always something of interest, whether you view it as an AMP or as mirrored or 2-cycle. Okay, so we're kind of limiting ourselves here, so we're going to go ahead and just view it as a mirrored structure. Well, this is kind of nice. We have a 1 and 2. They're both ace and 2. They're both black. Oh, this is wonderful, actually. Sorry. Okay, black, red, black. Check that out. and none of them match in suit, but they match in color. Wow. So you could, I don't think that would be too hard to remember if this was the whole routine. You just remember that you have 3 pairs that match in color, but within each pair, they're of different suits. How likely is that? Well, not very likely, and even less likely that you could possibly know that after the mixing we're going to do. So that is actually wonderful. So we'll view it as mirrored, and so here we'll just say 3 pairs, and they're all the same color within each pair, that is, but different suits. Okay, and you can see that if we were to view it as an AMP or a 2-cycle, that wouldn't be the case, right? Because, so for example, as a 2-cycle, the 2 of spades, queen of spades would be, quote, related as a 2-cycle, but they're of the same suit. Okay, so anyway, this is wonderful. As a mirrored structure, that may have actually been the strongest choice for a reveal. Okay, now we're ready. We're ready to start here. Okay, well, we've started, but okay, so what we're going to do now is I'll just pick up, this is the AMP packet, so just remember that this is an AMP. In fact, maybe I'll move this over the top just so we can see things a little bit better. Okay, so just focus on the fact that this is an AMP, and let me bring up our table of shuffles so that you can reference the table on the left as you follow this chain of arrows here. Okay, now what I've done here, there's nothing special about the particular way in which I've gone through this table and kind of connected things together. Okay, so there are I'm not even sure, millions upon millions of ways of using the table on the left to either preserve a structure or convert it from one to another. Okay, so I just happen to choose these particular paths, but there's nothing really special about any one of them. Okay, so here we are. We're viewing this as an AMP. Okay, so the first shuffle that I recommend, and it's one that we haven't shown you yet, it's called RLR. And that first R here stands for random. Well, it's random up to a point, okay? So when you do an LR shuffle, you do left, right, left, right, left, right. That's an LR shuffle with random stacking. Well, what the RLR is once you deal out one level, so we've built up one level, you don't necessarily have to put this one there. You can put it there or here. So that's the, quote, random part. So you have the spectators say, oh, you want it on that one? Okay, now we'll finish building that level. Now where would you want this one? Over here? Okay, very good. And now if you randomly stack these, you are guaranteed to get a 2-cycle. It's going to be a 2-cycle relative to the characteristics that we focused on down here. Okay, so this is, quote, a 2-cycle structure. Well, once you know it's a 2-cycle, there's great things that you can do with a 2-cycle. You can do a random cut. Spectator can cut this and cut off as many cards from the top and move that to the bottom. The Charlier shuffle, I have a separate video on my channel for the Charlier shuffle. This is a top to bottom, bottom to top, top to bottom. It's a very convincing shuffle. That shuffle doesn't hurt 2-cycle structures either. Okay, so this is still a 2-cycle structure. Now what you can do here to get to a mirrored structure, if you just look over here on the chart of a 50% coding, that's line 5. What this will do is if you count out half the cards, 1, 2, 3, drop the rest on top, then that will convert it to a mirrored structure. It's mirrored now. I do want to point out something called a supercoat. A supercoat is right below it. The only difference there is when you do like 1, 2, 3, and normally you'd put the rest on top, you can actually put the cards that are on the table on top of the ones still in your hand. So you can stack them in the opposite order. So that's called a supercoat. Once it's mirrored, we have something called the stay stack principle, and that's the one mentioned in part 1, where for every divisor of the packet size, you can deal the cards into that many piles and then randomly stack from left to right or right to left. And it preserves the mirrored structure, it won't hurt it. Okay? So we can do like left, right, and then ask the spectator, do you want left on right or right on left? Okay, very good. Now, the amazing thing is you can do as many of those LR shuffles as the spectator calls for. You can do one of them or 5 million of them, okay? None of those will hurt the fact that it's still mirrored, okay? Now, because the number 3 also divides evenly into 6, we can deal into 3 piles, like so, with random stacking from left to right or right to left. So let the spectator choose that. And you can repeat this LR3 as many times as you would like, or the spectator asks for. Okay, and now if we come over here to the Pharaoh, look up the Pharaoh, it's line 12. This also preserves mirrored structures, the Pharaoh. So how the Pharaoh shuffle works is you have the cards and you split them exactly in half. So I'll take the bottom half here, and then you just perfectly interlace them. Now, depending on how you interlace them, one is technically a Pharaoh in, and the other one's a Pharaoh out. Well, guess what? Both of those preserve mirrored structures, so it actually doesn't matter. So I'll go ahead and perfectly interlace these. Okay, there you go. So that's a Pharaoh shuffle. And so this is still mirrored relative to the special characteristics that we made note of, right, for pile 1. And then we're going to do something called a mange. So that's line 13. And this is a powerful shuffle as well. It will take you from an AMP to a mirrored and from a mirrored to a 2-cycle. Now, the mange shuffle comes in 2 varieties. One's called an over-under and the other one's the under-over. Both of them work just fine. They will convert a mirrored structure to a 2-cycle structure. Okay, so why don't we do maybe an over, under, over, under, over. So that's a mange over, under. It is now a 2-cycle. Now that it's a 2-cycle, if you wanted to, you could cut it. You could do some Chardelier shuffles. You know, this top to bottom, bottom to top, like that. Okay, but let's go ahead and just finish this particular column here of shuffles. Okay, now we're going to finish by converting this 2-cycle to something that's called a DMP, distinct mirrored pairs. That's all it stands for. So let's go back, let's go to the full hidden structures diagram that we showed you in part 1. So if you come over here, now the 3 structure types that we're focusing on in this particular series really are the 2-cycle structures over there, and then to the right we have mirrored, and then down here below we have an AMP. Well, off to the right of the mirror there's something called a DMP. And so what this is you're just, like with an AMP, as you go down the packet in pairs, each pair is related, has some kind of special relationship. Well, a DMP is where you take those pairs, those special pairs, and then you just set them into separate piles. So you have a pair of cards here, a pair of cards here, and a pair here. The cards within each pair are related to each other in the way that you've chosen at the beginning. Okay, so really a DMP is just a way to divide an AMP into separate pairs. Okay, now there's a number of ways of doing it depending on where you're starting from. So here we're starting at a 2-cycle. We have a 2-cycle now. Okay, so you can do something called an LR inverse. Okay, and so the LR inverse is, as you might guess, it's a shuffle that undoes the effect of an LR shuffle. But the mechanics are as follows. You have to be aware of how many cards you have. We have 6, and you divide that by 2, so that's 3. So what we're going to do is we're going to deal out the cards into 3 piles. 1, 2, 3. 1, 2, 3. Well, if you just think about it, let's go back to our simplified diagram, and I think you'll see what's going on. So we had a 2 cycle just a second ago before doing what we just did. So you can think of it as like 1, 2, 3 followed by 1, 2, 3. Well, if you deal out the top 3 cards, each into its own pile, a first pile, second pile, third pile, and then you deal out the remaining cards again, first pile, second pile, third pile, you'll be grouping the 1s together, the 2s together, and the 3s together. So it really just becomes like an AMP down here, but the cards are like divided into separate pairs on the table. So this is called a DMP. Okay. Now, what we know about this is what we made note of at the beginning. Remember, pile 1, all the pairs will consist of cards having opposite parity. Okay. So what that means then is this pair has an even and odd value card in it. So does this one. So does this one. Okay. So you could kind of make a game of this. Since these supposedly have opposite parity, it's kind of like having opposite charge, or like magnets where you have a north pole and a south pole. Well, the north pole and south pole attract each other. So you could say, well, I'm trying to get a feel for like if these are both even, both odd, that kind of thing. Whoa, whoa, they really are pulling towards each other. These must be of the opposite parity. Oh, for sure. Those are attracting each other with a very strong force. Oh, wow, this one, they just want to almost click together. Same thing here. Isn't that curious? What about the last one? Are they repelling, which would mean they're of the same parity, or are they attracting? Ooh, this one's a bit weird. I'm not sure. If I had to guess, I think they're of opposite parity. I think I'm feeling just a slight attraction between them. So I'll go with that as my final answer. I believe all 3 of these pairs consists of cards having the opposite parity. So let's just check that. Oh, check that out. That's an odd, this is even. Opposite parity. Oh, even odd. Opposite parity. Now this is the one I was getting kind of mixed signals on. Well, what did we find? Oh, a king. Let's see, king, jack 11, queen 12, king is a 13. Yes, this is a 13, which is odd. And 6 is even. Yes, indeed, they're of opposite parity. How in the world was I able to sense that? Okay. Well, you didn't sense anything, right? It's just mathematics that allowed you to finish with these pairings because you knew the original structure type, namely it was an AMP relative to these features that we just, in fact, we just stacked these right now. It's almost like we're back to the beginning. This is an AMP. You could go through this whole thing again, right? But we knew the original structure type. We knew what these shuffles would do, either preserve a given structure or convert it. And then in the end, we knew exactly the characteristics of interest to us of those pairs of cards. And we were able to reveal that indeed each pair consists of cards of the opposite parity. Okay, so anyway, that's the first demonstration. Starting with an AMP. Okay, let's work with the mirrored structure now. Hopefully that's the right one. It should be the middle one. Okay, so if this is mirrored right off, then that means you have the stay stacked principle that's at your disposal immediately if you want to use it. And once again, the stay stacked principle says that for each divisor of the packet size, you can deal the cards into that many piles and then randomly stack from left to right or right to left, and guess what? The resulting packet is still mirrored. Amazing. Okay, so that's what I suggest here. Maybe you do a left-right. Ask the spectator, do you want me to stack left on right, right on left? Very good. And then I kind of suggested maybe do a second one. You can actually do as many of these as you like. Okay, you want left on right this time? Very good. And then maybe we'll do it in the 3 piles, and you can, ask the spectator if they want you to do that. You don't have to, but if they do, here we are. And now you just ask them, well, should we stack from left to right or right to left? Well, left to right, maybe. It wouldn't matter, but they can state, okay? And so it's still mirrored. After all of that, it's still mirrored. Okay, so to go from a mirrored structure to a 2-cycle structure, there's multiple ways of doing that. One is using the Mange shuffle. Okay, now we've already shown you the Mange shuffle once. So if you come over here to the Mange shuffle, it states that you can go from a mirrored structure, which is what we have right now, to a 2-cycle. And that's what we're indicating on our paper. So why don't we do, I think the first time we did a over-under, so why don't we do an under-over, under-over, under, okay? That works fine to convert this mirrored structure to a 2-cycle. Well, once it's a 2-cycle, you can do the Chardelier shuffle, or just have the cards cut randomly by the spectator, okay? And so it's still a 2-cycle. A wonderful way to go from a 2-cycle structure to an AMP is to use the Pharaoh shuffle. So look here at line 12, the Pharaoh shuffle. It will take you from a 2-cycle to an AMP. Okay, now we've used the Pharaoh shuffle once already in this video, so we'll just go ahead and do it again. This is where you split it off like this so we can kind of see the cards. You take 1/2 of them, and then you interlace them perfectly. So maybe we'll have the one on the right above, the one on the left at the very bottom, and then just interlace them. And that is a Pharaoh shuffle, and that will always convert a 2-cycle structure to an AMP structure. Now I do want to point out that we used the Pharaoh shuffle for a different purpose last time. Pharaoh shuffle actually leaves mirrored structures alone. Isn't that interesting? So for mirrored structures, this is a structure preserving shuffle, but for 2-cycle structures, it's a structure converting shuffle. So now we're looking at an AMP. Okay. And then since this is an AMP, what that means then is in pairs as you go down, each of those pairs will be the pairings that we noted at the beginning. Okay, so a pairwise transpose, this is where you go like 1, 2, 1, 2, 1, 2. Now technically to complete the pairwise transpose, you would then stack from left to right, but we're just using it as a way to get our pairings. And so we have our pairings, meaning we have a DMP. These are distinct mirrored pairs. And so we can now reveal what we noted. Do you remember? We had 3 pairs of the same color, but different suits. So none of them matched in suit, but they all matched in color within each pair. Okay, so you have to realize that I'm not really dressing these up all that well. I'm probably more excited about the mathematics of everything on this channel than I am in being a consummate card performer. So there's so many ways to kind of dress this up. The mathematics is making the impossible occur, and then you can sell it in however you would like, using your personality and your creativity. Okay, so we know that these are of the same color, right, within each pair, but different suits. Okay, so I mean, you could use that same little trick I did. Since they're the same color, they would have the same charge or magnetic properties, and so same color. See, these would repulse. Oh yeah, there's definitely something strong there pushing us away. Okay, so that would be one. You could do that for each of those if you wanted, and then even before you turn them over, say, well, I can tell that they're the same color. I'm not sure about the suits, but for some reason, I feel like there's a conflict there within these pairs where none of them actually are of the same suit, despite the fact that they are the same color. Okay, so however you want to sell that. So you can say, well, oh boy, this first one, it really feels like those are both the same color. Was it? Oh, I was right. Check that out. They're both black. This one, I can't tell that. Oh, yeah, this one for sure. Yeah, this is just crying out to me. These are of the same color as well. Oh, yes, indeed, they're both red. This one, I don't know for sure. If I had to guess, I think these are of the same color as well. I mean, that's what I'm kind of getting as an impression. Oh, they are indeed. Check that out. Black queen with a black 4. Okay, so however you want to, like I said, dress it up or personalize it in a way that makes it fun for the spectator, that would be wonderful. Okay, and so we just have one more to go for this video. So we've done an AMP structure, a mirrored. So let's take a look at our last one, which we set up as a 2-cycle structure relative to these properties here. So there's 2 pairs of the same suit. That's really nice. And then there's a pair not of the same suit, but of the same color. Now, if you want to squirrel away that it's a red pair, that might be fun to reveal. I mean, the more information you can remember, the better, really. But if you can just remember, okay, 2 of these pairs have the same suit, and then the remaining pair, it's not the same suit, but it's actually still the same color, and I think I'm seeing red. I think they're both red. Now, something I should point out before we finish with this one is you have to realize that we are, for the sake of this video, doing 3 different routines, kind of all at once. So it would be hard to remember all of these, but you have to realize that you would just do one of these. You know, like this one here. This would be the only one, and this is the only information down here you're needing to hold on to. Okay, so I want people to realize that and not become overwhelmed and think, I can't remember all that. So you're just needing to remember that for this particular packet that we've set up. In some ways, we didn't set it up. That I shouldn't have said that. It was randomly dealt out, but we noted some structure of interest, and that's actually pretty decent structure there, to have 2 pairs of the same suit by a random process, and then have the remaining pair be of the same color at least. That's pretty unlikely, you would think, right? Okay, so this is a 2-cycle. Well, we've mentioned that you can do the Chardelier with a 2-cycle, a random cut, but what I decided to do here is just jump right into converting it to a mirrored structure. So if you come over here to line 14, the Klondike shuffle, it's a very, very useful shuffle. It'll take you from a 2-cycle to a mirrored, and from a mirrored to an AMP. Isn't that nice? So, so right now, being a 2-cycle, if I perform a Klondike, and we perform Klondike shuffles in the first video of this series, but we haven't yet here. So this is where you take the top and bottom card off as 1 and set them down. Top and bottom off as 1, set those down, and then there's only 2 left. So that's called the Klondike shuffle. And what it's guaranteed to do to a 2-cycle is it will convert it to a mirrored structure. And I want to point that out. Now, you do need an even number of cards for everything that we're kind of doing in this series right now. But if you have an even number of cards and you have it set up, or it is set up as a 2-cycle, a Klondike shuffle will always, always, always convert it to a mirrored structure. Whether it's 4 cards, 6, 32, 112, as long as it's even, it's going to work. So it's a mirrored structure now. Well, now we have the stay stack principle. Okay. Oh, and I do want to point out something that I've kind of glossed over. I'm calling this the LR3. And partly because I think it's a kind of a clear name for it. You're doing a left-right, and now we're going to do 3 piles, right? But what it relates to on the table is the RC shuffle. Let me point that out because I have mentioned that. So if you look at line 10, something called the RC shuffle. R is for row, C is for column. Or you can just think of it as a factoring of the packet size. Like here, 2 times 3 is 6, or 3 times 2 is 6, that kind of thing. But when it's mirrored, that kind of shuffle leaves mirrored structures alone. So this is the stay stack principle, really, in force right here. Okay, so the LR3 just means do it into 3 piles, like we've done earlier, with random stacking from left to right or right to left. Maybe if they ask for right to left, that's fine. And then we can just do an ordinary LR, and we can do as many of these as well as the spectator calls for. So that won't hurt the fact that it's mirrored. An even or odd up jog. I don't know if we've used that. We haven't used that to preserve a mirrored structure in this current video. We did last time. So an even or odd up jog. So this is where you push forward or jog up either the even position cards or the odd position cards, and then strip them out. So right now I have like the second card is being jogged up, 4th and 6th. Okay, so it's like I'm doing what's called an even up jog, and then you just randomly stack these. Well, that action actually preserves mirrored structures as well. Okay, and now we're going to do one that we haven't shown you. It's a really cool one, powerful one. It's called an alternate Klondike. That's what the AK stands for. AK down here, alternate Klondike. And so as you can see, what is it? The longest chain, isn't it? It will take you from a mirror to an AMP to a 2-cycle to a mirrored. It will do a complete cycle. So you can go all the way around. Just this original little chart here that we had, the simplified version, you can just go round and round kind of thing. Okay. Now there are restrictions for some of the legs of that journey, if you notice. So going from an AMP to a 2-cycle, you do need a multiple of 4 for the number of cards for it to work. And the same thing, if you go to a 2-cycle structure to a mirrored structure, you'll need like a packet of 4 or 8 or 12. 12 is what we used last time. 16, 20, 24, that kind of thing. But right now, we're looking at a mirrored structure, and there's no restriction. So going from mirror to AMP will work using this alternate Klondike. Well, as the name suggests, it involves the Klondike shuffle, and you alternately set the cards down into a left pile and then a right. Okay, so here we just start just like a regular Klondike. So you go left, then top and bottom, go to the right, only have 2 left. That one would go on the left. So you just left, right, left, right, until you run out of cards. And now you can stack these in either order. Isn't that wonderful? Okay, and once you've done that, you'll have what's called an AMP, which we've worked with already, of course. And then there is a shuffle that will leave the AMP structure alone. It doesn't actually have a name that I'm aware of, so I gave it a name. I call it a Bessie 2-2. Okay, there's also a Bessie 1-1 that we'll look at if we haven't already. Maybe we can talk about it in the next video, but it's similar. A Bessie 2-2, it will preserve an AMP structure. So a Bessie 2-2 is done as follows. You hold the cards just like you're doing a Klondike, but now you take a card from the top twice. You go 1, 2, and then you take a card from the bottom twice. So I'm taking from the bottom now. 1, 2, and then you take from the top again. 1, 2, 1, 2, and then you just repeat those actions until all of the cards have been moved from one hand to the other. And that kind of shuffle, and if you give it a little bit of thought, you realize that should leave AMP structures alone. Remember, the AMP structure at the very bottom is like you have a 1, 1, 2, 2, 3, 3. Well, with this Bessie 2-2, it's like you're taking the top 2 off, dropping them into your hand, other hand, and then you take the bottom 2 off, I guess, which here would be the 3-3, and then the next top 2 would be 2-2. So you'd be leaving them in blocks. Because you're taking 2 at a time from the top or bottom, it will leave AMP structures alone. It won't hurt them. Now, it does rearrange the pairs, the 1, 1, 2, 2, 3, 3, but that doesn't change the fact that it has that characteristic that every pair taken from the top is related in the special way that you've set up at the beginning. And then finally, we can change this to a DMP by doing something I call POP, push off pairs. Now, if we go to my chart, my table there, I give it a more general name. It includes the push-off pairs as a special case. It's down here, POE. That stands for push off any even number of cards. So you can push off 2 or 4, 6, okay? So any even number. So we're going to go ahead and just push off cards in pairs. But that kind of mixing of the cards will preserve mirrored structures as well as AMP structures. Isn't that great? Okay, so push off pairs, this is where you don't necessarily rearrange the cards in the pair. It won't hurt if you do, actually. So you push off a pair, and push off the next 2, and then push off the final 2. And now this is officially a DMP. These are the pairings that we wanted to preserve at the very beginning. And then if you remember, what we noted is that 2 of the pairs have exactly the same suit. And then there's one final pair. The cards in that pair don't have the same suit, but they are of the same color. And that color is red. Okay, so however you'd like to reveal the fact that you know that. So 2 of these match and having the same suit. Oh, there you go, both clubs. And then one won't have the same suit, but they'll match in color. And that would be this one right here, right? So not the same suit, but they're both red. And here we go, those match in suit as well. They're both diamonds. Okay, so I am hoping that with part 1 and part 2 behind us, you're getting a feel for and getting comfortable looking for these different structures within any random even-sized packet of cards, okay? And then once you know what you're going to work with, if you treat that packet as having the structure type that you have imposed on it, then you can preserve it, convert it from one to another, preserve those, then convert it from one to another until eventually you reveal the pairings that you've already made note of at the very beginning after you've been handed a random packet of cards, in particular here, 6 cards. So thank you for watching, and if you haven't watched part 1, take a look at part 1. It may fill in some of the gaps, and then look for additional videos within this series dedicated to Improv Card Magic. So thank you again for watching.